Okay, so we were supposed to do the odd problems on this worksheet. We're factoring by grouping. Let's take a look at number 3. When we look at number 3, we see that we've got the 4 terms. And if the directions say factor each completely, and you see that your problem has 4 terms, that's a clue that it's going to be done by factoring by grouping. Done by grouping. So we're going to group these just like we see them. Group the first 2 together. Group the next 2 together. Once we have our groups, we're going to find the GCF of each group and factor it out. So the GCF of 3 and 4 is just 1. So you don't factor out a 1, all right, unless that's the only thing that's there. We also have an n cubed and an n squared. The GCF of n cubed and n squared is n squared. So we're not going to write the 1. We're just going to put n squared. And then we have to finish it out as to what's left when we factor out the n squared. So 3n squared cubed divided by n squared leaves 3n minus 4n squared divided by n squared, which is 4. Okay. All right. In the next group, we find the GCF of 9 and 12. 3. And then when we factor out the 3, what's left is? Good. So notice that we've got the same binomial factor. That's what we want. We want a common binomial factor. If these factors are not the same, then you either did something wrong or you would need to rearrange the terms. Well, I'm not going to give you problems where you have to rearrange the terms. Therefore, if these are not the same, you did something wrong. So now we factor out the common binomial factor, which is 3n minus 4. And what's left, when we factor it out, is n squared plus 3. So our final answer is this product of binomials. You don't have to expand it or anything. If you expanded this, you would get back to where we started. We want the factors. These are the factors. Okay? Let's go to number 5. Number 5, we're also going to group it like we see it. So what's the GCF of the first group? M squared. Okay, when we factor out the m squared, what's left?
1m.
M minus 1. All right, in the second group, what's the GCF of 2 and 2? 2. And what's left? M minus 1. Okay, if you did what you're supposed to do, it should be m minus 1. Yes?
I'm not really sure on how you get like a 1. I understand.
Well, what's 2 divided by 2?
Oh, okay, I forgot about that.
Okay. All right, so now we've got our common binomial factor. Let's factor it out. M minus 1 will go in front, and that leaves m squared plus 2. Now, technically, do I have to put the m minus 1 first? No. I just choose to do that because I like to think of it as factoring out the common binomial factor and putting that first, but you don't have to. Okay, let's skip down to number 9. Number 9, notice there is a minus in the middle of number 9.
Second term.
So the second group, for the second group, you will put your parentheses around that minus. Now, that means I've got to throw in a plus in between those two groups because that's what's really there. It's really, you could think of it as plus negative 5nz. All right, so just to make sure you're not thinking of this as multiplication, throw that plus sign in. I know there's not much room here. All right, now we find the GCF of each group. So the GCF of this first group is m. And when I factor out the m, what's left?
M minus 5h.
Well,
Is that it? What is that m squared?
z,
Oh, z.
yeah, z minus 5h squared. The m got factored out. Okay? And then, whenever we are grouping the negative, when we put the minus, when there's a minus in the middle, we put our parentheses, you're going to factor out a negative. So the GCF of -5 and 25 is -5, so minus 5. There are n's in both places,
N and 5n.
and so -5nz divided by -5n leaves what? Z.
Z plus 5, 5h.
Good. So you should have the same thing you had in the first parentheses, right? We're doing everything right. We can almost assume that it's going to be right. You got to be careful when you assume, because you know what they say. All right, so z minus 5h squared times m minus 5n. That's your final answer. Okay, so that is factoring by grouping.